FST students, this is the back page of the Chapter 3 test. Number 3, you were to graph the solution set of the given system of inequalities. And so looking at this particular graph, this first graph is x is less than 2. Now that's just one variable x. It's linear. This would be a vertical line through 2. It would be dashed because it's less than. And would be shading to the left of that. The second particular inequality is linear. It's in standard form. So what I would do is I would find my intercepts. Covering up the y here, I have 4x is 4, so my x-intercept would be 1. So I'm going to make a point at 1 on the x-axis. Covering up the 4x part, I have negative y is 4, which means y would be negative 4. That would be my y-intercept. So I'm going up 4 and over 1. This is going to be a solid line. And then testing a point, because it's in standard form, if I would test the point 0, 0, 0 is not greater than or equal to 4. Therefore, I'm shading on the opposite side. So I'm shading left of the vertical line and on the non-0, 0 side. So the shaded area would be this area right here. (3b), the first one, look at that, I see it's a parabola. I also see that I could write it as negative x squared plus 4, just changing the order of that. So therefore 4 is the y-intercept, that's the c value. Since my a value is a negative 1, I would go over 1 down 1, and then over 1 down 3. And then we have the dashed parabola. And it is y is by itself, less than, means you'd shade below it. So this would be underneath the parabola here. Then the second part you can see is linear. It's in slope-intercept form. My y-intercept would be a positive 2. My slope is 1, a positive 1. I'm going to go up 1 over 1. This is going to be a dash line. And since y is by itself, greater than means above. So I'm below the parabola, above the line. I'm in this little section right here. So those are graphing solution sets of inequalities. All right, number 4, and you'll have to look at your test here for the problem. But reading through the problem quickly, it says cars and trucks are made in a factory that is divided into 2 shops. Shop 1 performs basic assembly, working 6 person days on each truck and only 3 person days on each car. Shop 2 performs finishing operations, working 4 person days on each car or truck that it produces. Shop 1 has 150 person days per week available, while Shop 2 has 120. The manufacturer makes a profit of 500 on each truck, 350 on each car. Now, here's the most important sentence right away. It says how many of each should be produced. So what we're producing is cars and trucks, so I'm going to let those be my variables. And then it says to maximize profit. So that's the objective of the problem. I'm going to write a profit equation. And that equation is we're going to make $350 on each car and $500 on each truck. Then I'm going to draw a line separating that because I'm not going to graph that profit equation. Now, reading through it more carefully, it does talk about shop 1 and shop 2. And shop 1 is going to perform 3 person days on each car. So each X has 3 days, each truck has 6, and shop 1 does have 150 available. And then also shop 2 performs finishing operations, 4 person days on each car and on each truck. And that has 120 hours available in shop 2. And then we have our kind of obvious X has to be greater than or equal to 0 and Y has to be greater than or equal to 0. So now we're going to graph these constraints. So I've got the X is greater than or equal to 0 as a vertical line through 0. Y is a horizontal line through 0. In the first inequality, the x-intercept is 50, and the y-intercept would be 25. And then in the second inequality, both my x-intercept and my y-intercept would be 30. So those are my 2 lines. 0, 0 makes them both true. I'm shading below both of them. So this is our feasible region. Most important points of the feasible region are your corner points, which are 0, 0, 0, 25, 30, 0. And then this point is where the 2 inequalities will cross. All right, so solving this system of inequalities, I'm going to multiply the top by 4. So if I multiply the top one by 4, I'm going to have 12x plus 24y is equal to 600. Multiplying the second one by negative 3, I'd have negative 12x, negative 12y is a negative 360. X is eliminated, I end up with 12y is 240. So y would be 20. Then plugging 20 back in to one of these equations, I would find my x to be 10. So this corner point right here would have the coordinates of 10, 20. And then you're going to plug each of those in to this profit equation. So putting 0, 0 in, I'm going to get 0. And then I'm going to put in 25 in for 500. Bear with me here a second as I grab my calculator. So 500 times 25 is 12,500. I'm going to put 30 in for x, so 350 times 30 is 10,500. And then I'm going to take 350 times 10, which is 3,500, plus the 500 times 20, which is 1,000, and I get a total of 13,500, which is, you can see, the maximum. And that is when we would produce 10 cars and 20 trucks.